Hi everyone, it's Professor Lushin. This is an interesting situation. There's been a delay in me getting this lecture and the other lecture out this week because I had some technical issues. In resolving the technical issues and assembling this particular lecture, I made the realization that the demonstration I was going to provide to you of residential electrical systems would have actually violated the arc flash or the NFPA 70E. I wasn't using insulated tools, and for working with live equipment, I wasn't wearing the proper PPE. So I'm glad that we had the technical issues. Otherwise, I was just going to record a tour of the inside of an electrical panel and the inside of some junction boxes and show how everything works. But and I've worked around a live equipment before, and I'm just very careful. I use administrative controls, but that would not have been a good precursor to this lecture. So I just wanted to let you know that. So I'm just going to stick with this lecture. I do have some really good videos, as you can see on the screen. Here's a demonstration of it, and then we've got an NFPA 70 approach. You know, it's a demonstration. It's pretty good. And then I've got some really good links as well. So this should give you, between what I'm going to show you and what I'm going to talk about, that it should complement what I'd wanted to cover anyway. I brought up the concept of insulated tools, and you're going to see them in the videos too. But so I'm going to show you a very quick set of, I don't know why it went all the way down. Sorry about that. I was reading about it. Here's a very good set of tools. Some pliers, some screwdrivers. Looks like it's from Home Depot. They want to know where I am. Costs about $35. So anywhere from probably $25 to maybe up to $50, you could get a really good set of tools. To be safe, though, and I just went to a Grainger site. I don't know if you can see this, but this 8-piece set of insulated tools is $350. Insulated tools are much more expensive, but if you're going to be working around live electrical equipment, this is really what you should have. And after I've been reading and preparing for this, I realized that. I'm glad I didn't demonstrate what I would do normally. Do as I say, not as I do. Isn't that how all parents put it? All right, so let's talk about arc flash. So the first thing I want to show you is sort of the breakdown of how dangerous it is working around electricity. And so I've got 4 different slides here just on this one page. And depending on what your source is, you know, they can say that there are, you know, so many actual shocks per day. A certain percent of them end up in burns, and then a certain percent end up in hospitalizations or possibly fatalities. And there's anywhere from, I believe, 250 to 500 fatalities a year. But then on the upper right-hand corner, you see that even though it's a declining trend for non-fatal electrical injuries, and this goes up until 2015, and the number is just under 2,000. So and then on the bottom right, it shows that they can be very expensive. In fact, it says total costs, including litigation, can be 8 to 10 million. I have a friend who works in insurance, and he claims he has told me stories that their most expensive claim is still open. It's over 17 million as of now, and it was due to an arc flash. One person survived the blast, and they were in a burn unit, intensive care burn unit for, it was like a month, and it was like over $100,000 a day, and now they've got all kinds of other issues. Now you're probably wondering, what is an arc flash? We've seen some exploding stuff. Here's 2 versions. Essentially, let's say that my left hand, which would be on your right, is the neutral pole. And let's say my right hand is the hot line, or the energized line. But when they're separate like this, everything's all right. What you need is an accidental connection. Let's say my glasses become that connection. As soon as that connection occurs, all the energy wants to, I guess the hot wants to jump to the neutral. And the problem is usually the device that is causing the crossover or the connection cannot withstand that energy, and therefore it essentially evaporates and explodes at the same time. So a solid metal turns into a vapor and droplets. And I think it says on here, okay, the bottom left, copper vapor, solid to vapor expands 67,000 times. 67,000 times. So, think of the volume of your fist. And if I was to put 67,000 of them around it instantaneously, there's just huge pressure or percussion wave that blows things out. And that's what it's showing here, the top right. Temperature is between 15 to 20,000, and I believe that competes with like the heat of the sun, but it's smaller. It accelerates particulate at about 740 miles per hour. So there's shrapnel, molten metal, heat. There's also ultraviolet radiation, and so there's radioactive. It's super loud. It blows out your ears. And there's also this thing that's going to blow you back. So these things kill. You might think, well, how does this happen? If you're working around live equipment and you're not working with insulated tools, it sometimes happens that you accidentally make two contacts that you didn't mean to. That can happen. So they want you to wear proper personal protective equipment when you're in those situations. The problem is it's cumbersome, and it actually makes the job a lot more difficult, which means why I can see why people would want. But there are some horrible pictures online of what happens when metal fume, or I should say metal vapor, absorbs into the skin and then cools. It's like a Doctor Doom type thing if you watched any of the Fantastic Four movies. Whenever you go up to an energy cabinet, a circuit breaker panel, whatever, you should see a warning label such as this. You can, if you're ever on campus, walk through the hallway, you'll see these on there. Certified electricians have completed these labels. It indicates, based on the amount of voltage in the design of the cabinet itself, it lets you know what are the minimum arc ratings, the arc flash boundary, the type of glove that's required, the energy at an incident, the shock risk, anything over here. It just basically has information about the cabinet and what would happen should it become an arc flash site. So this is a demonstration of the boundaries. You have restricted space, and limited approach. And the amount of PPE one would require to withstand an arc blast or an arc flash is dictated by it. Because I think as you double the distance, it reduces the energy because it's expanding out. Unless you're in like a corridor in which it can't expand out, then you're going to have to back it up further. So it's how the energy could be released and dissipated over space. Here are some calculations that can go into it as far as the energy level, what type of equipment. So over on the left, we've got how the stuff is calculated, and this would be like a list of arc flash cabinets. And so this would be the list of what you'd have to fill out for the labels to go on the different cabinets. So there are equations you can use, but would you want to do that without being a licensed electrician? I wouldn't want to do it. I think I could figure it out, but I wouldn't want to do it. I'd pay the money to have them do it. Over on the right, we've got what the four categories of hazard assessment, therefore dictates what the PPE is required. And then it gives you the arc rating of the PPE for calories per centimeter squared. That's, you can see that's the incident energy level, and that's what finally dictates what must be worn. But they do have, they also calculate all this other stuff, energy in the arc, working distances, and things like that. That all dictates what is the arc rating or the calories per centimeter squared that the PPE must withstand. Over on the left, I've got the natural rubber electrical insulating gloves. We've got color, and we've got what the label looks like. So that's just for the gloves, and that's what's going to make it so difficult to work. In the video, it shows that the worker tests all the equipment so they know what's going on in the full PPE. And then what they do is they systematically go through and lock it out so that the system can be worked on, de-energized. Then they can take off all their PPE and do the work. But the design of the system itself may negate that ability. Because if you're unable to lock it out, if it's live to everything, you wouldn't be able to do it. So in that case, what you'd probably want to do is somehow shut off the energy to your building, to the main energy source, and start building in switch boxes or sub panels that allow you to actually lock things out so things can be worked on. So some of it's electrical design, some of it's actual procedure. Over on the right, I've got a list of the different types of PPE. And when I do this lecture in class, the guy who does the guest lecture brings in all this equipment and we put it on a student. The student's like, oh, I don't like this because it's super warm and it's super heavy. So you just imagine, guys working out in the field, and let's say it's a hot summer day. You don't want to be in that very long. You're going to be like sweating like crazy, and it's probably fogging up. You want to get the system locked out so you can work on it de-energized. Here's a poster which provides a breakdown of the different types of PPE depending on the category. And so it's got the calories per centimeter squared, and it's got all the different elements. I just thought this was interesting. And on the bottom, it's got the NFPA 70E noted. That's what this is. An NFPA 70E designates that how to assess what the arc flash arc blast potential is. And once you've completed that worksheet and created the label, that what does a person need to wear in order to do the work? Yeah. Here's some more information on boundaries and PPE. And I did this. I provided 3 different slides here so you could see the consistency of it. Now, after seeing everything we've talked about here, and this is what caused me to say, it would have been foolish of me to have a video of me taking the face or the front panel off of a circuit breaker panel and like showing you it was live and all the components. That would have been dangerous. That would have been a bad thing for me to do to you. Do to you? To show you. That's what I mean. Here's more information, arc flash, PPE, and clothing. I mean, the further you go up in numbers, the more you look like an astronaut or an alien, to be honest with you. Now what I'd like to do is just share with you some pictures and things I had cited that were related to electrical, just so you can kind of see some pictures. So the top ones are housekeeping, but at the bottom one here, you can see that they have a circular saw plugged into an extension cord. And what I found is they were using the circular saw, it's a DeWalt, but when they set it down, the cord actually got caught in the blade. And then what I did is I looked at the cord, and I even noted a few times they do this regularly. They're damaging the insulation. This thing should be taken out of use. Yeah, there's a better word for it. Out of service. It's better. Another one is space to be able to access a power center or a circuit breaker panel. So this circuit breaker panel is rated at 480 volts. You'll notice it doesn't have the arc flash sticker on it. This inspection I think was done over 5 years ago. I'm not sure how well versed I was in NFPA standards at that point, but so they should have had that as well. Though I'm not sure where you'd cite that in the OSHA standard. There is something on arc flash. If you can't open the door all the way, you can't properly access it. You can't take the care you need to do it. And this wood is flammable, and so if something was to happen, it could be just a very minor arc. It could catch us on stuff on fire and take down the whole building. Yeah. Here is temporary wiring. And what's interesting, I just had a student from the class ask me about this, that on here, OSHA allows the use of temporary wire extension cords for up to 3 months. And he had found that 90 days, right? The standard itself says 90 days. I said here, and it will cite if over 6 months. So OSHA basically, as a compliance officer, instead of saying, oh, this is 91 days, and therefore they could probably disavow it, because how is it tracked? But if you have enough workers say, oh, it's been here over 6 months, then we could cite it. Because otherwise they could fight it. So even though the law says 3 months, or the standard says 3 months, we usually would let it go up to 6 months. That was a compliance officer thing that we did. Any equipment should be plugged right into the wall. Though that system is designed to handle the electrical load. These extension cords or multi-strips are not. They should only be used for audiovisual equipment. That's it. That's all they're designed for. And then here were the citations that were written, and you can see anything that is a 1910, 300 something. I've got a 334. Is that it? We got a 303, a 305. Those are all electrical violations, and those were only $7,000. That was 5 years ago. Remember we talked about the penalty amounts? Back then it was $7,000. So obviously it was like before 2016. Here was another site. Here I really got into inspecting their panels. I did have a video of me showing them how I reviewed it, but it was very jumpy. I even got a little motion sickness. I had mounted a GoPro to my chest. I need to find a better way to film that stuff. But you can see here, there's been, when you have an open, what do they call those things now? Knockout? That means it was used by something before, and now it needs to be filled in. I thought I had one over here that I could show you. So it needs to be reblocked. Or if you run like wire through it, it needs to be secured. Or if you run a conduit out of it, it needs to be secured. So they had a lot of electrical issues at this place, and you see they're just building up here. Oh, I even cited a licensed electrician should conduct arc flash potential for all panels for minimum compliance and create arc flash labeling, and that's 1910-303E. So I did find it. So this was later on. This might only be like 2 years old. Extension cords were used all over the place. There was some piggybacking where you're doing extension cord on multi-strip. They were running them through, around edges and through walls and through doorways, and they need to hire an electrician to come in and put in permanent electrical lines and circuitry and make sure everything's all right. Even in their office, there were busted or missing covers, and these were all live. I tested them, and I also tested polarity, and I think those were pretty much okay. More issues, places where you need to put in GFCI if it could be wet. So if there's a water source, there's just problems. Here, on the bottom, I was referring to the charging station. I mean, that's somewhat electrical. Due to all the electrical issues on this particular site, it accounted for about 43% of all of their citations. So what I was basically 43% or almost $45,000 in penalties. I was trying to give them a basis for if you get a bid from an electrical contractor that could do all this work up to code and keep it under $30,000, you'll have saved $15,000 should OSHA ever show up. That's what I was trying to show them. And again, these are not maximum amounts, these are adjusted penalties. So that's the way I roll. So I think this is this is like the third site. So we're citing again the boxes and circuit breaker panels not being properly protected. Here we had damaged or in-house repaired cords. Can't do that. Overuse of multi-strips and extension cords, just a mess. People don't think because, it's not shocking anybody right now. It's like, but the potential's there. It could happen. Here's some other problems. They needed GFCI. Plugging in something like, I think it was a Coke machine into a multi-strip. You can't do that. It's not rated for it. And then there was evidence of rodent infestation. Again, plugging in appliances into a multi-strip, you cannot do that. More electrical issues. Here was an interesting one, the bottom right. This was the circuit breaker panel in the kitchen. That thing was steaming hot to the touch. What does that mean? It's being overdrawn. So what they really need to do is bring in an electrician and see why it's being overused. Why is so much energy being drawn through it? Why is it so hot? It's not that and what they may have done is actually somehow jerry-rigged it so that it's able to draw more amperage than what the design of the box is. Eventually, it's going to degrade anything in there that is metal, plastic, and you're going to have exposed lines. There's going to be a problem. Bottom right, you had equipment that was outside that was becoming rusted and damaged. It's got to be repaired. And here's just some laziness. Yeah. So their penalty amounts, I'm looking for the 300s. It was a major part of it. Yeah, I just off the top of my head, it looks like that could have been at least a third, if not up to maybe 40% of all the citation amounts. So that's pretty much everything I wanted to cover, other than I do want you to watch the additional videos that I had posted on the site here. They're not that long, and that should give you enough basis to understand the importance of arc flash, and that you shouldn't be doing any electrical work at home. Having a licensed electrician do it. Do as I say, not as I do. All right, thank you.